Now that we've looked at how to interpret the slope and intercept in context, let's go ahead and practice that skill. So our first example is an example that relates your miles per gallon that you would get in the city in your vehicle versus the miles per gallon you get when you're doing highway driving. So usually that highway driving, you get better miles per gallon. And so we have a formula here. The highway miles per gallon is equal to 6.785 plus 1.033 times the city miles per gallon. So you're going to identify the explanatory and response variable, the slope and the intercept, and interpret them in context. Decide if the intercept is statistically meaningful. And then there's a prediction that you're also asked to make for both of those. So go ahead and work on this first one. Pause the video and give that a try. All right, so hopefully you gave that a try, and let's go through it and make sure that we're all on the same page with this. So the first thing I need to do is identify my response variable and my explanatory variable. Typically, my response variable is this one that's all by itself, right? We have a y equals, and the y is our response variable. So here I have highway miles per gallon equals. So highway miles per gallon is going to be my response variable. And the words, or if that's an X that's attached to a number, is generally going to be your slope. So since city miles per gallon is attached to 1.033, the explanatory will be the city miles per gallon, and the response variable will be that highways miles per gallon. All right, so the slope is the number that's attached to the explanatory variable. So that's 1.033. And that's a positive number, so that makes it just a little bit easier to write that sentence. And so if we interpret this in context, we'll get as city miles per gallon increase by 1. So each time my city miles per gallon gets better by 1 mile per gallon, my highway miles per gallon increases by 1.033 miles per gallon. And then my intercept is usually this number that's all by itself, so 6.785. Remember that intercept is when our x is 0, so x is city miles per gallon. So when city miles per gallon is 0, the highway miles per gallon will be 6.785. So the next question is that actually make any sense in the real world? No, it doesn't. The intercept is not statistically meaningful because I don't know of any way that I would have a car that doesn't drive or doesn't get any miles per gallon in the city, but magically can drive on the highway. That seems a bit unrealistic. So I would say this one is not statistically meaningful. And then we were asked to make a prediction. If your car gets 16 miles to the gallon in the city, what's your miles per gallon going to be out on the highway? And so when you plug 16 in for X, you get about 23.3 miles per gallon on your highway driving. All right, so hopefully that went well. And now that we've gone through one of them, let's go back and do this other one. So this last one that you're going to look at, too far there, is this shrinking forest. So scientists measure the annual forest loss in square kilometers, so that's indicating that quantitative variable, in Indonesia from 2000 to 2012. So they gave us a regression line, and the one thing to note here is that the regression line for predicting forest loss in square kilometers, they're counting the years since 2000. So if we were looking at the year 2004, then I would use x equals 4 because it's 4 years from the year 2000. So I know that's a little bit of an awkward way of doing that. That is a kind of a common thing you'll see in a variety of fields. So just keep that in mind, but go ahead and pause the video and give that one a try as well. All right, so hopefully that went well. Let's go through these. So again, that explanatory variable is usually what's attached to this number. So the years since 2000 should be my explanatory variable. And my response variable is this forest lost. The slope is the number attached to the explanatory variable. So 1021, also positive. So I'd say as the number of years since 2000 increases by 1 year, the forest loss increases by 1,021 square kilometers. So each year we're losing about another 1,000 plus square kilometers of forest. The intercept is going to be the only number by itself, so the 7,500. And there's a couple ways you could write this interpretation. Since x equals 0 is the year 2000, we could write when the year is 2000, the forest lost is 7,500 square kilometers. You could have written when the number of years since 2000 is 0, the forest lost is 7,500 square kilometers. So there's a couple of ways you can kind of word that one to make it make sense. But ultimately, what we're essentially saying with that sentence is in the year 2000, we lost about 7,500 square kilometers. I would say that this one is statistically meaningful, and that's because they were collecting data in the year 2000. So it's actually within the set of points. And so this is most likely going to be a statistically meaningful intercept. And that sentence does make some sense. And then the prediction, we were supposed to predict how much forest is lost in 2022. So that means I would use x equals 22. So it's 22 years since the year 2000. And when I plug that in, I get 29,962 square kilometers of forest lost.